Welcome to the Relaunch Your Career podcast. I am your host, Leah Lambert, career and interview coach and founder of Relaunch Me, where we help you find the work that you were meant to do. Welcome to episode 38 of the Relaunch Your Career podcast. Today we are talking all things science with Dr. Carli Roulston. Carli is a neuropharmacologist and has 20 years' experience working in the field of neuroscience with the University of Melbourne, the O'Brien Institute of Microsurgery, and the Florey Institute, which is the largest brain research centre in the Southern Hemisphere. Carli has spent the last 3.5 years at the Florey Institute as head of laboratory and more recently moving into a program manager role, where she has specialised in research to promote recovery after stroke. Carli has also worked for many years as a lecturer in the Department of Biochemistry at the University of Melbourne. She's served on the board of the Stroke Association Victoria for 3 years and was also the founding member of the International Stroke Recovery and Rehabilitation Alliance. Carli is super passionate about neuroscience and also about helping others, particularly women, develop a sustainable and fulfilling career within the field. Welcome to the podcast, Carli.
Thank you, Leah. That makes me sound really good. That's a lovely introduction.
There is so much more that I could have said about you, but we would be here all day.
That's very nice.
Look, thank you for joining me. I know this is an area, like you are super passionate about your field of science, but also about careers and helping other people. So I thought it'd be great to have you on the show today. Can you tell us how, I guess, it all began for you and how you first came to choose science as a career?
Yeah, well, in year 10, I had a really great chemistry teacher who had identified that I love to ask difficult questions about how do we know something is true and where does this information come from and how is the information discovered. And so he actually set up a wonderful work experience program for me at the Baker Institute of Medical Research, which is now Australia's and the world leading medical research in cardiovascular disease. And it really did not take me very long to work out within that 2-week program that I wanted to be a pharmacologist. And I actually wrote the word pharmacology down and I carried it around in my purse for many, many years. And when anyone asked me what I wanted to be, I always said I wanted to be a scientist and particularly I wanted to be a pharmacologist. And a pharmacologist is somebody who studies the effects of drugs on the body. And it's really a crucial link to getting medicines out into clinical trials to help people with diseases. And that's really where I wanted to be. I wanted to be a scientist and I wanted to be helping create new medicines for people to help people with disease.
It's quite rare for someone so young to be so focused. I think you were really lucky to have that focus from such a young age, and how amazing that your teacher could give you that opportunity, which gave you a chance to actually experiment and test something out. So at the end of schooling, you went and studied a Bachelor of Science and then went on to your honours year, which I think you finished with first class honours, which is no surprise to me. At the end of your bachelor degree, what were the different options that you had to consider?
This is a really great question because this was a big turning point in my life. At the end of honours, I had really enjoyed the whole entire program, but I wasn't certain at that point in time that I wanted to continue with research. And I actually went to a number of industry-held events to look at all different pathways associated with the pharmaceutical industry. These included the regulatory affairs pathways, the clinical trial pathways, the drug development pathways. And in that process, I actually thought that I would choose one of those pathways and go into industries directly. But it was actually a really dedicated supervisor that actually filled out my PhD scholarship application at the university and came to me one day and said, "Would you please sign this?" And I said, "What is it?" And he said, "Oh, this is an application for a Monash scholarship. I think you would be throwing away some serious talent if you were to not pursue a career in science." And so I signed. and then went on to do a PhD in neuroscience and looking at the effects of brain inflammation after a brain injury. And I have no regrets whatsoever. Again, it was always part of my passion to pursue research, science as a career. And I guess he recognised that. And I'm here today because of that.
So, Carli, everyone hears about PhDs, and I feel that there are a lot of people out there, probably including myself, who don't really understand, what that exactly means on a day-to-day basis. How are you actually spending your time when you are doing a PhD?
Yeah, it's effectively similar to if you were working as a research assistant or anybody who already had the qualification. Basically, you're given a research project. You have to plan out the experiments for those projects, and then you have to undertake those experiments in order to generate the data for analysis and presentation. So from a day-to-day basis, it depends on the project, but generally speaking, you'll be working either in a team or with your supervisor to establish protocols and process that you then take into the laboratory, and then you actually do the experiments to generate the data yourself. Once you've got this data together, as a PhD student, you're expected to analyse the data, interpret the data, and come up with future directions yourself. So outside of a PhD, you might not be asked to do all of that, but this is really an apprenticeship where you're going through the motions and your supervisor is preparing you for one day to own your own research, to think creatively, to come up with new ideas, and then one day to manage your own lab and supervise your own students and bring in funding to support research that then continues on that developmental pathway to help others.
That's a very good description. Can you tell us what your topic was for your PhD and also how you chose that?
Yeah, so it's quite a long time ago. I'm trying to think of what the topic of my thesis was. Basically, in a nutshell, we were comparing different methodologies on how to study brain inflammation. And there are two specific types of cells in the brain. They're called glial cells that actually respond to brain inflammation. And we were looking at different markers of how we could quantify that effect really fast and efficiently. And so what we were aiming to do was basically end up with a radioactive label that could potentially be used in MRI studies in people that could quickly tell us whether or not somebody had an inflammatory event that was potentially dangerous or, on the other hand, potentially growth supporting. And in actual fact, some of the markers that are used in PET scans today have evolved from that research platform from, a very long time ago now.
Wow, that's amazing. Yeah, that must be very fulfilling. So you completed your PhD. Can you talk us through some of the different roles that you've had since then?
Yeah, so they've been varied. I initially started as a postdoc in the stroke research laboratories at Monash, and my role was to investigate drug treatment effects on that brain inflammatory response using the markers that I developed during my PhD. And that was a wonderful experience because I learned a whole series of new techniques and a whole industry specific to stroke. From that position, I was actually recruited to the Florey Institute as the lead neuroscientist on a commercial development program that was looking to design and carry through to market a new drug to treat brain injury after stroke. And I spent 4 years in that role. And in that specifically, I had to deliver research that was to GLP standards, and that's good laboratory practice, that would result in a product that then could be screened by the FDA for approvals to clinical trial. So that was my first exposure to an industry-based commercialisation project, but where I was for the very first time leading the research myself. So nobody was necessarily giving me a research platform. I was helping to create that platform. And then from there, I went into roles as a supervisor where I started to be the one who was passing on my knowledge and developing up others in the research space. In that position, I started to take initiative as a woman in science, and I started to implement some women in science forums at St Vincent's campus That was when I was at the Florey Institute and Department of Medicine. And I think it was probably at this point in time that I probably stepped up to take a more stronger leadership role in the senior scientist community there, and had a real passion for supporting women through the transition, because we are outnumbered generally in the science field. And I really wanted to be a champion for the voice of women who sometimes weren't as outspoken in the industry, but we all really needed to collectively speak as one.
So what would be some of the job opportunities that someone, when they first finish their PhD, what would be some of the typical roles that they would look for?
Yeah, so now I think we could say that the roles were more varied. You have a choice to continue science, and in that choice you could become a career postdoc where you're working at the level of what is expected as a PhD. So you'd be managing a project, interpreting and analysing and presenting that data. But you might not necessarily be expected to write grants and apply for fellowships and support your own salary. And we sort of refer to that as a career postdoc. You could also take the other side of things and become more independent, drive your own research funding, and be working towards actually having your own laboratory and managing your own research team. And that's what we traditionally referred to as like the fellowship system. We call it laboratory heads, faculty members, etc., sit into that bracket. And that's really a pathway to associate professor level as your career progresses. You could also choose to do some further education in terms of teaching, and a lot of people choose to go into an academic position at a university and lecture and research at the same time, or you could just become a lecturer. So there are different options now where you don't have to lecture and research. And then, of course, there is industry. And so industry is always keen to engage with new PhD students who are fresh, who've got great critical thinking, have an ability to obviously interpret information and communicate information. And so there's multiple different pipelines. Also, there's also a lot of more venture capital opportunities now to work with investment companies to then identify research and be part of teams that actually look for research to invest in. So career choices are multiple, and I've just mentioned the ones that are specific still to science. So there are so many different ways that people can take their critical thinking, their really great management skills, their really great time management skills and communication skills into just so many different aspects of the workforce.
There's lots of opportunities there for, and you know, depending on their personality and I guess where their level of interest is, lots of different pathways there. Can we just go back a step? For someone who perhaps doesn't want to go on and do further studies, so even someone who completes a Bachelor of Science, what would be the career options for someone who perhaps doesn't go on to do honours or a PhD?
Well, within the Florey, we've got a number of different levels of research engagement. So there is technical support, there's research assistant support where you don't need to have any of those higher education levels, and where training as a research assistant takes you through to that really level of a PhD completion, but just in that research assistant side of things. A lot of graduates will often go into careers outside of science, or will go into support roles. So there are many different opportunities within universities, like within the grants teams, within the finance teams, for graduate level. Internships exist across hospitals in different departments for people just to transfer directly from a degree. Obviously, I didn't choose that pathway myself, so I'm actually not as familiar with what happens there. But also, I think it's really important to say that the changing systems in terms of education means that a student doesn't necessarily have to finish a degree and make a decision straight away. So with all of our postgraduate courses now, you don't have to have done an undergraduate in a law-based process to be able to apply for postgraduate law. And so we find that a lot of our science students really diversify later on, and they might take a couple of years off in the workforce, but then come back and do postgraduate studies. That's just a change in our education approach, and that's really been, I think, really fantastic for young people, because they can do an undergraduate, they can get a few years' work experience, and then they can go back and pursue further activities later on.
Yeah, exactly. Actually, one of my good friends, she'd worked in science for years and years. I think she actually worked at the Florey for a while. And I think around the age of 40, she went back and studied law postgrad and is now working as a lawyer in intellectual property. So there's certainly plenty of time to diversify later on. Carli, I know you have achieved a lot in your career to date, but can you tell us what some of the most rewarding parts have been for you?
I think that supervising students to completion and seeing where they go on from there. I have an amazing contact and relationship with the people that have come through my laboratory, and they have gone on to do some really fantastic, amazing things. Only one of them is continuing a career in science, where she's now managing her own laboratory in Germany. But I'm all really proud of the different achievements that people have made. I think for me, from a personal perspective, the most amazing thing that I achieved in my career was my engagement with the stroke community. It's something that scientists often overlook when they're really deep diving into their science and they're getting stuck into their laboratory research. They often forget that there is a really strong human side to the disease in which they are investigating. And I really encourage anybody in the science community who is in that space to reach out to the people who you are actually trying to help. And I learn a lot from our stroke community, because what we think is important as scientists may not always translate to what somebody who is going through the journey of recovering from a stroke sees as being really important. And so for the 3 years that I worked with the Stroke Association on the board of directors, I'm really proud of where we took the association in that time. I'm really proud of how the association is moving forward now. And I think that as a scientist, being involved in a community support program was not only beneficial to the science, but I think really important when outreaching to community.
That's fantastic advice. And I think, you have always shown that human side and that the passion for what you do. Every career has its pros and cons. What would you say are some of the frustrations that people may need to be aware of if they were considering a career in science?
This is the one that I always refer back to. So my chemistry teacher back in year 10, when I came back all excited, I'm going to be a scientist, he said to me, yes, but there's no money in science. And I didn't quite understand what he meant. I'm like, well, that's okay. I don't need any Gucci handbags just yet. And I have a completely different understanding of that for now. So funding is just so difficult to achieve and to really support our science in Australia. We have a funding system that is really, really underdeveloped. And so every year a scientist has to apply for grants to not only have funding for their own salary in the following years, but the salaries of the people who work in their teams. And if you don't get a grant that year, it means that you likely have to let go of someone within your team. And that is one of the hardest things that you have to do, simply because there is not enough money devoted to medical research. And it doesn't matter if in the last grant you achieved all of your objectives and you have a product that is on its way to market, you still might not get funding to take that further. And so it's shelved. And it's so frustrating when great research has to sit on the shelf because you don't have funding to take it further. And I think that was probably that's the most heartbreaking aspect of, for any scientist's journey, is having to continuously apply for grants, and then when you don't get grants, having to deal with the fact that your research can't move forward.
And so for someone when they don't get awarded that grant for that year, does that mean they may have to look for another job?
Oh, absolutely. So we have people who unfortunately leave science every year. There's a proportion of people that are forced to either perhaps find research opportunities in other labs that have been successful in their grants, people are often looking from transitioning out of full-time science into academic roles because there's more job security associated with that. But yeah, I'm an example of having really been forced to think about where I want to be in 5 years' time, and do I want to still be doing this when your funding, when your funding runs out.
So, Carli, you recently, you had been working as head of laboratory for, I think it was over 3 years. Can you explain sort of what happened there and then why you moved into the program manager role?
Yeah, so in actual fact, I took on head of laboratory role back in 2009. So, and I grew the team and transitioned to the Department of Medicine at University of Melbourne, and then I moved to the Florey in 2018 because I had two things in my portfolio that the Florey was suited to support. One was an industry project that I was working on, a project with actually Professor Ian Fraser on developing new treatments to target brain inflammation. And the other was a commercialisation project of my own, looking at a device intervention to support stroke recovery. And the Florey is really well renowned for their commercialisation strategies. And so it was a really great fit to move across to the Florey. And as such, I got an opportunity to integrate within the Florey faculty and be exposed by some of really the world-leading neuroscientists working in all different aspects of neurological disease. And the Florey is also well renowned for its clinical outreach. And there is a lot of clinical trials and there are a lot of clinicians who engage with the Florey. So it was a really fantastic opportunity for me because I really prided my research in being translational.
So, Carli, quite recently you moved from a scientist position or head of laboratory position into a program manager role. Can you explain what transferable skills you were able to take from one role to the other?
Yeah, so it's really interesting that when you're faced with having to restructure your CV, you do ask yourself as a scientist, what skills have I gained that is transferable to a project management office and project management styles and techniques? And what's really interesting about even those words, and there are so many different acronyms that are used in the management world, that I actually had to Google some of these things. What are project management strategies and what skills are associated with those? So I did a few little short courses and realised that, I was using most of those in my everyday working life. So the things that are transferable is that we undertake very clear research strategies that are planned out, where A leads to B leads to C. And so that's a classic waterfall approach to managing a project. But as scientists, nothing ever goes to plan, and you don't always get the results that you are looking for, and you have to often diverge and create a new plan, which is an agile form of management. And then we have mixtures of management where, which are referred to as iterative, where you move between the different styles. And so I realised that a lot of the techniques and skills that would be otherwise used outside of science were being used in the laboratory every day. Good communication is really important in science. If you don't have good communication skills, it's really hard to get funded, and it's really hard to get your papers accepted for publication. If you don't have really good time management skills, you just can't get things done in the pace that needs to be done in order to apply for that next grant opportunity or the next funding opportunity. You also need to have really good leadership skills because you're supervising and you're teaching people all the time. You're transferring your knowledge. And finally, I think that the interpersonal skills that you develop as a scientist working with multiple stakeholders, so like cross-population of people's personalities. And sometimes I do describe scientists as like being in an episode of The Big Bang Theory, and working out how to negotiate yourself through that is, really sets yourself up to being in a position as I'm in now as a program manager, where I'm supporting a whole range of different projects and people through the process of delivering commercial and a new medicine to treatment.
You've explained that really well. And I think that is something that I find a lot of researchers and scientists find it really hard to articulate the soft skills. They're very good at explaining their technical expertise, but really find it really difficult to actually articulate and identify all the other skills that they're using every day.
Yeah, and I think it's also important, and I'd just like to plug this at this point in time for anyone who's listening and thinking about transitioning out of science, is to really seek some help and guidance in reformulating your CV, because scientists will prepare a CV that very much supports how many publications they have, how many awards they've achieved, what grants funding they've had in the past, and what skills they're good at the benchtop. And just would really suggest that someone get some extra support in refocusing and remodelling their CV to identify those skills that I've just spoken about and present them for an alternative career.
Yeah, that's exactly. There's a big difference between an academic CV and a corporate CV. And I think have to, as an academic or someone from a research background, have to really think, is this huge list of publications actually relevant, or should I just choose my top 4?
Absolutely. So when you're applying, say, for example, for a project management position, which requires you to have some knowledge of financial acquittals and reporting, it probably really does not matter how many times you've published in Nature.
That's right. Yeah. And it is really hard because they're, things that you've put a lot of time and effort into. It's hard to sometimes remove those things from your resume.
Yeah. And just in light of that, anybody who's managed their own laboratory before or managed a laboratory-based project has experience in financial budgeting. They have experience in reporting, and they might not just realise that they have that experience.
That's exactly right. Carli, what sort of advice would you have for some, possibly for a young student who is just contemplating a career in science? What would your sort of, say, 3 or 4 key pieces of advice be?
Yeah, well, I think that it's really important to scope out all opportunities. So for me, obviously, at the time that I entered science, I had a really narrow focus about what I wanted to do. But I think it's really a good idea to think about science as not just one single pipeline to a particular goal. There's multiple opportunities along the way. I would then say, if you do have a tunnel vision for a particular goal, don't be discouraged if you don't achieve your goals straight away. There are multiple different pathways that you can take, and sometimes the direct pathway doesn't always give you the skills and the life experience that really can set you up for success later on. I would also encourage people to be really great communicators about their goals, not to just sit back and think, I'm going to wait for it to come to me. Be really proactive in how you go about achieving your goals. So if you're wanting to do honours, be really proactive about contacting potential honours supervisors well in advance. Know who it is that you're speaking to before you call or before you arrange a meeting, and make certain that you know what their project is before you actually have that meeting. And that is one of the things that I did when I applied for honours. Went to the library, I downloaded my supervisor's papers and I read them, highlighted them, so that when I went to the honours interview, I was asking them questions about their research, for which I think they were quite surprised because they hadn't actually had that happen before. Now, since that time, I've had students come and do that with me, and that always makes a lasting impression. If someone goes to the effort to get to know you and your research before they come and speak to you about that project, it means that they're really serious. Now, that goes the same for when you're applying for any job. I would advise people, don't just submit your CV and your cover letter and wait for someone to contact you. I would suggest that you should always ring the person who is employing, ask if you can speak to someone for more information about the project or the particular job in question. Ask some specific questions so that you can get ideas for what you need to put into your cover letter and your CV, and then apply. And so being proactive, I think, is a really important component to being successful in science.
Such good advice, Carli. I think you could almost make another career change into become a career coach with those pearls of wisdom.
Well, as a team leader, that's what you're doing. You're helping people in, that's what a really good laboratory leader does is career coach people into different opportunities. It's just narrow, that's all.
No, look, I know that you would be a fantastic leader and mentor to those people. Carli, I feel like we could talk all day. You've got such a wealth of information there, but I did promise I wouldn't hold you up for too long. Thank you so much for coming on the show today and sharing this your experience and your wisdom in the field of science. It's been an absolute pleasure having you on the show.
Oh, thank you, Leah. I've always been one of those people that always wanted to share knowledge and success ideas with others to help other people in their own career paths. And I certainly have to thank you, because obviously my engagement with you and your company and your team has just been outstanding. And a lot of the things that I've spoken today I learnt from you.
Thanks, Carli. Have a great day. And thanks again for all your great pieces of advice.
You're welcome. Thanks, Leah.
I hope you enjoyed this episode of Relaunch Your Career. If you did, please subscribe, share with your friends, leave a review, or connect with us on social media at Relaunch Me Career Consulting. If you have any questions about the episode or the work that we do, then contact us via the website relaunchme.com.au. Thanks for listening. Have a great day.